Hi, Olarewaju Bolarewa is my name. Teaching is my calling. What do we have for today? We are still on Surds. This is the advanced level of the Surds, where we will be treating the conjugate of a binomial Surds. So before we proceed, let's see a skeletal view of how conjugate of a binomial Surds is processed. This is structural view of how a conjugate of a binomial Surds is solved. Whenever the denominator have an operation, either addition or subtraction, we process this by interchanging the operator in between the two roots that we have at the denominator position. So as this is addition, we are going to multiply both the numerator and the denominator by the function we have at the denominator position, of which we are going to change the addition sign to subtraction. Now this will result to having a all over what we have here, which is root b plus root c. We are going to multiply what we have here by the same figure here, but this addition sign will change to subtraction. So we have root b minus root c. As we have it here, so we do it for the numerator. We are going to multiply this same value here with the numerator. Root b minus root c. And if this was a minus, we will have used an additional sign to join the two functions. So what do we have next? A multiplied by root b will give us a root b minus a root c. Everything all over root b multiplied by root b, we are going to have a b. Root b multiplied by minus root c, we are definitely going to end up with minus root bc. Equally, root c multiplied by root b is going to be addition of b times c. Either cb or bc, they are the same. So we will be having bc again when you multiply this and this together. And finally, root c multiplied by minus root c, we are going to have minus c. Then we could choose to factorize this one, which will give us a open bracket root b, this is the minus here, then we have root c, close bracket, everything all over, minus root bc plus root bc. You have root bc and you are owning root bc. So eventually these two will cancel each other. Then we shall be left with b and minus c, which will give us b minus c. So this is just the structural view of how we will solve conjugate of a binomial Surds. So the next one is going to be an example so that we can see how we can make use of this to solve questions on conjugate of a binomial Surds. We have these two examples here. So for this one, before we can proceed, solution for the first one, we have an operation, we have these two roots which we are going to get the conjugate of, and we are going to use it to multiply both the numerator and the denominator. So before I proceed with this, I can choose to simplify it first, or I use it directly. If I want to simplify it first, I'm going to say 6 multiplied by 4. I would prefer to simplify it first. Then I'll be having 12 all over 4 multiplied by 6 minus root 6. The root of 4 is going to be 2. So I'll be having 12 all over 2 root 6 minus root 6. So fortunately for me here, I have a root 6 and another root 6. So I'm adding 2 of the root 6. Then I'm to remove 1 of the root 6. So I'll be left with 1 root 6. But I'm not going to write coefficient of 1. I'm rather going to write just root 6. So this will give me 12 all over root 6. And if you have been following the previous classes, you will remember that I told you that under no condition should you leave your answer when you have the denominator having roots. So we are going to rationalize this. And when you want to rationalize this, we will have 12 multiplied by root 6. We have root 6 all over root 6 already present, root 6 multiplied by root 6. So for this, we have 12 root 6 all over root 6 multiplied by root 6 will give us 6. So we have 6. So 6 goes here, takwa, 6 goes here, takwa. This gives us 2 root 6. Easy. The other way around, for this same first question, I didn't think I chose to find the conjugate instantly. I'll still end up to have the same answer. Let's see how it goes. For this same question, using the conjugate of the binomial sort, this subtraction will become addition. Then I'll use that value to multiply both the numerator and the denominator. So let's proceed with that. 12 open bracket root 24 plus root 6 close bracket. Now for the denominator, root 24 minus root 6 close bracket. We are going to use it to multiply this again. Root 24. This time around we are using addition as we have done for the numerator. So plus root 6. Then we open the bracket. Here we have 12 multiplied by root 24. This will give us 12 root 24. Likewise for this, plus 12 root 6. Then we have for the denominator position. Root 24 multiplied by root 24 will give us 24. Instantly, we have 24. Root 24 multiplied by root 6. I can say we have plus root 24 multiplied by 6. Then for this, we have minus 6 multiplied by root 24. It's still the same thing. It means it will give us minus either 6 multiplied by 24 or 24 multiplied by 6. They are the same because 2 times 3 is 6. 3 times 2 is also 6. So let me deliberately write 6 multiplied by 24. And finally, minus root 6 multiplied by plus root 6. Minus times plus, we have minus. So root 6 multiplied by root 6, we have minus 6. On to the next step. This is root 24. We can break it down by saying 12 root 24 is still the same thing as 4 multiplied by 6. And for this, we see our 12 root 6. For the denominator now, plus root 24 times 6 minus root 6 times 24. They are the same, so they will cancel each other. So cancelling each other will leave us with 24 and what? And minus 6. Now the root of 4 is 2. When we get the root of 4 to be 2, that will multiply it with this 12. It gives us 24. So we have 24 root 6. Now plus 12 root 6. We have 12 root 6. Everything all over. Now we have 24 minus 6. And 24 minus 6 will give us 18. We have 18 here. So looking at this, if I have 24 of root 6 and I am to add 12 of root 6 to it. So by the time I add 12 of root 6 to 24 of root 6, this will give me 36 of root 6. 24 of root 6, root 6 in 24 pieces, and I have root 6 in 12 pieces. By the time I join everything together, it gives me 36 of root 6. So this gives me 36 of root 6 all over 18. By the time you cut this, 18 here Takwa, 18 here Takwa, we are left with 2 root 6. In case someone has missed something, 18 here 1, 18 here 2, we have 2 root 6. As you can see it here, you can see it here. Easy. So, to the second question, we have root 8 and all over root 50 minus root 2. You can either choose to first simplify root 50. And when you simplify root 50, you are going to have 25 multiplied by 2. Let's try to do it that way. So we have root 8 over root 25 multiplied by 2. Then we have minus root 2. While we are working on the denominator, we also remember that this numerator, which is root 8, can equally be simplified. So if you want to simplify this, you have it as root 4 multiplied by 2. So everything all over root 25 is going to be 5. This gives us 5 root 2, then minus root 2. Then the next thing is root 4, which is going to be 2. Then we are left with root 2 inside. Everything divided by root 5 root 2 minus root 2. I have root 2 in 5 places, and I am to remove a root 2 from this 5. So I'll be left with 4 of the root 2. So I have 4 root 2. So I can cut root 2 here Takwa, root 2 here Takwa. 2 here 1, 2 here 2. I'm beautifully left with 1 all over 2. That's my answer. Easy. The other way around, if I choose to first use the conjugate idea, which is going to be root 8 multiplied by the conjugate of the denominator here, then I'll be having root 50 plus root 2. Everything over the denominator, root 50 minus root 2 multiplied by root 50 plus root 2, as we did for the numerator. For this, I can simplify this and simplify this, or I use this to multiply the 50 instantly. This will give me root 400. We have root 400. By the time I multiply 8 and 50, then root 8 multiplied by root 2 will give me root 16. Everything all over root 50 multiplied by root 50 will give me 50. I have 50. Then root 50 multiplied by root 2 will give me plus root 50 multiplied by root 50. I add 50. Root 50 multiplied by root 2. This will give me root 100. For this, minus root 2 multiplied by root 50, it will give me minus root 100, and finally minus root 2 multiplied by root 2 will give me minus root 2 times root 2. That will give me 2. The next thing is to simplify this. Root 400. I can also write it as 4 multiplied by 100. For this, without wasting time, I have it as 4. By the time I find the root of 16, I have it as 4 already. And as a matter of fact, by the time we find the square root of 400, it's going to give us 20. But doing it this way, no crime. There are many ways we could solve this, but this is rather quite a little bit longer than how we're supposed to solve it. So I'll still have, for the denominator, root 100 minus root 100. This will give me 0. They cancel each other. Then I'm left with 50 minus 2. This is 48. Now, this is going to end up to be 20. Or I say root 4 is 2, root 100 is 10. As we are doing it already, so we have root 4 to be 2, multiplied by root 100, which is 10, then plus 4. Everything over 48. 2 multiplied by 10, we have 20. Then 20 plus 4, it gives us 24 all over 48. So by the time you cut this, 24 here 1, 24 here 2, we are left with 1 all over 2. Isn't that easy? So half here, half here. Having done this, I'm going to leave you with a task under this before we move to trigonometrical ratio, leaving our answers in surd form. Before we move into the examples or tasks from conjugate of binomial surd, I do like us to quickly have a look at the trigonometrical ratio of the three angles given here: the angle 30, angle 60, and angle 45. Of course, how these values are derived shall be well treated when we get to the topic so catois from finding the side and angles from a right angle triangle. So without wasting time in this tutorial session, we are having our values already derived for sine 30 to be half, for cos 30 to be root 3 all over 2, for tan 30 to be 1 all over root 3. Furthermore, we have for 60, sine 60 to give us root 3 all over 2. Sine cos 60, I beg your pardon, is equals to half, and tan 60 equals to root 3. For sine 45, we have 1 all over root 2. For cos 45, 1 all over root 2 again. And finally, for tan 45 to be equivalent to 1. We are using these values instead of making use of the decimal that we are going to get from our calculator. If you check, by the time you punch your calculator, sine 30 will give you 0.5. 0.5 is still the same thing as 1 all over 2. Likewise, when you just pick at random, tan 30 will give you a value in decimal. But by the time you check the equivalence of this to what we have here, 1 all over 3, you will see that they will be the same. So that's the essence of surd. Surd is meant for us to solve our answer or get solutions to our answer in such a way that it will be well compact together and usable for subsequent questions, if peradventure we need to still make use of them without using calculator. Now we have this question from a right angle triangle where this side is unknown, likewise this place is unknown, and we have to leave our answers in surd form and not in decimal. Now let's proceed. From our idea from so catois, so is SOH, which stand for opposite over hypotenuse. This shall be well treated when we get to trigonometrical ratio as a topic on its own. Now let's see what we have here. We have our solution. sine 60 equals to opposite over hypotenuse. That is 9 over x. And for our sine 60, which is root 3 all over 2 for its equivalence. So we are going to have root 3 all over 2 equal to 9 all over x. So when you cross multiply here, we are going to have x root 3 equals to 18. But we are basically trying to make x subject of the formula. So by the time we divide both sides by the coefficient of x, which is root 3, we are going to have x equal to 18 all over root 3. We cannot leave our answer like this. Based on what you've learned from Surds so far, we are going to rationalize what we have here. So rationalizing this will mean the root 3 will multiply both the numerator and the denominator. So we have 18 root 3 all over root 3 multiplied by root 3. X equal to 18 root 3 all over root 3 multiplied by root 3 will give us 3. 3 goes here, tap 1. 3 goes here, 6. X is equal to 6 root 3. That's our answer for that. Easy. Alright, having done this, now let's move towards our y. For us to get y, we can use any of the two formulas, either cos or tan. Using cos 60 will be adjacent over hypotenuse, or tan, which is opposite over adjacent twice. Let's start with cos. For cos, we have cos 60, which is adjacent, this, over hypotenuse. Then we have y all over our hypotenuse, which we have got it to be 6 root 3. So, checking what cos 60 is. Cos 60 is 1 all over 2 half. We have cos 60 to be 1 all over 2 to give us y all over 6 root 3. So by the time we cross multiply, we will be having 2y to give us 6 root 3. Our intention is to find y. We divide both sides by the coefficient of y, which is 2. So we have y equal to 6 root 3 all over 2. 2 goes here, 1. 2 goes here, 3. So our y ends up to be 3 root 3. Easy. Likewise, if we choose to use tan, let's verify if tan 60 will also give us the same value as y for the purpose of learning. Tan 60 now. Sorry, begin. Tan 60 is opposite over adjacent. Tan 60 opposite over adjacent, which is 9 all over our adjacent y. Tan 60 is given to us as root 3. Tan 60 is root 3. Root 3 equal to 9 all over y. When you cross multiply, you have y root 3 equals to 9. Dividing both sides by root 3, which is the coefficient of y, will leave us with y equal to 9 all over root 3. Here we are going to find the conjugate. Rather, here we are going to rationalize what we have here. So we are going to multiply the numerator by root 3 and the denominator by root 3. So y is going to be 9 root 3 all over root 3 multiplied by root 3. And this will give us 9 root 3 over root 3 multiplied by root 3 will give us 3. 3 goes here, 1. 3 goes here, 3. So y is equal to 3 root 3. We got our y to be equal to 3 root 3 here, and y is also 3 root 3 when we decided to use tan 60. Easy. So the second one, when you take a look at this, there is no way we can find our x directly, because by the time we bring out this right angle triangle, you only have this, but there will be this side, which is the opposite, and will not have any value for hypotenuse. For you to solve any side of the right angle triangle, at least a side must be given. And we cannot use the triangle from here to here to here, because it will not be a right angle triangle again. So what we could do here is to technically find what this place to this place is. So by the time we get this place, then we can now work it out by getting our x. So let's proceed to see how we go with it. So I'm going to pick the whole right angle as it is from the external part, which is angle 45 from here. This hypotenuse side is given to be root 2. So I can choose to easily find from here to here. So from here, my opposite is this, and my hypotenuse is root 2. So I'll now say, let me assume that this place is side Z. So as it is side Z, now let me use sine 45. Sine 45 degrees equals to opposite over hypotenuse. Z over root 2. Now sine 45. Sine 45 will give us 1 all over root 2. 1 over root 2 as our sine 45 implies. Then everything all over, don't get it wrong, this is Z all over root 2. So by the time you cross multiply this, you have Z, let me place it like this for clarity, Z root 2 equal to root 2. Then for us to know what the Z will be, Z is going to be root 2 all over root 2. So Z is going to be 1. Because root 2 over root 2 is going to be 1. 5 over 5 will be 1. 20 over 20 will be 1. 80 over 80 will be 1. Myself over myself will be 1. So we have this to be 1. Now we know that this place is equivalent to 1. Now moving on from here, we can now resort back to this triangle, this and this. I'll quickly draw that one out. We have angle 60 degree, a right angle triangle. We have x, but from here to here, we should call z is given as 1. Now we proceed again. If we choose to use sine 60 will be opposite over hypotenuse. We are not interested in finding this place, so it will be a waste of time. Let's try to consider cos. Cos is adjacent over hypotenuse. We've not found this, so we will not use that. It's not suitable. Definitely the third one will work, which is the tan. Opposite over adjacent. So we have tan 60 equals to opposite over adjacent. 1 all over x. Now what is the value of tan 60? Tan 60 is root 3. Tan 60, we have root 3 equal to 1 all over x. So when you cross multiply, we have x root 3 equal to 1. And we are interested in finding x. X is going to be 1 all over root 3. We cannot leave this here. We have to rationalize it. So x is going to be equal to 1 multiplied by root 3 all over root 3 multiplied by root 3. So 1 multiplied by root 3, we have root 3 all over root 3 multiplied by root 3, we have 3. This is our answer. Don't make mistake by cutting this and this. They are not, it's not applicable. So we have our x to be root 3 all over 3. The second one, which is the y. For you to get the y, we cannot isolate the triangle from here to here to here, because it's not going to be a right angle triangle again. So instead, what we are going to do here is to build the whole triangle together from the external vertices, from the external points here. So using this right angle triangle from here, I can choose to use cos or use tan. If I choose to use sine, sine will not work, because sine 45 will be opposite over hypotenuse, and the hypotenuse is already given, and we have equally found the opposite. But using cos, cos will be car, which is adjacent from here to here, all over car is adjacent over hypotenuse. So it will give me everything from here to here. And this is what will happen. Whatever we get from here to here, by the time we remove the value of x from it, that one will be the value of our y. I will repeat myself. If we get from here to here to the 7, and we have already gotten our x to be root 3 all over 3. So by the time we remove root 3 all over 3 from that 7, that is what will be our y. So we can now assume that from here to here is, we can just call it q. So anything we get from here to here, which is our q, by the time we remove x from it, it will be our y equivalence. So let's proceed by using either cos or tan. Let me choose to use cos 45. Let's see what will happen. So cos 45 equals to car, adjacent, everything here, over hypotenuse. So the car is opposite. Car, adjacent rather, car is adjacent over hypotenuse, which is q all over root 2. And cos 45 will give us 1 all over root 2. 1 over root 2 equal to q all over root 2 again. So by the time we cross multiply here, we have q root 2 equal to 1 multiplied by root 2. We have root 2 again. So moving further from here, we are trying to know what our q will be. So q is going to be equal to root 2 all over root 2. And root 2 over root 2 will give us 1. So it means our q is equal to 1. But that's not all. We have only gotten from here to here to be 1. Now what about from here to here, which is our y? Then we now say we remove the x from what we have here, then that will be our y. So y is equal to the q, which is 1, minus our x. And the x we got was root 3 all over 3. So we can assume that this is over 1 again. So y is equal to the LCM of 3 and 1, we have 3. 3 divided by 1, we have 3. 3 multiplied by 1, we still have 3. Minus 3 divided by 3, we have 1. 1 multiplied by root 3, we have root 3. From here, there is absolute nothing to be done again. So we can say our answer is 3 minus root 3 all over 3. Easy. Thank you so much for your time. If you have really been inspired by the class, I would like you to please hit the subscribe button, share with your friends, and remember to like this video. I'm leaving you with this task. So this is for conjugate of binomial sort, and this one, I would like you to leave your answers in Surd form. Then you drop your answers at the comment section below. Till next time I see you, thank you and God bless.